Unit 4, which is on data and probability, and we're starting with 4.1 part 1. We're going to look at terminology. What are the names? What do we mean by all the words we use? First of all, the word data. Data is simply a word for information. We gather information, but you can gather all kinds of information. So we're going to focus on some specific ones. So discrete data will be things you can count. Even if you count in halves, still things you can count, like how many people at the concert, how many cars. But even the marks you got for a test, or the marks you got for various tests, you could have gotten half marks. That's fine. The other one is continuous data. Continuous data is things you measure. Because when we measure stuff, we always round the answer to a convenient number of decimal places. So distance, you would just say so many kilometers to Cape Town. You won't say so many kilometers, so many meters, so many centimeters, etc. Weight, even area, anything you measure is considered continuous data. Right, when we collect data, so for instance, if you're at a conference and you count how many English-speaking people, how many Zulu-speaking people, how many German-speaking people, etc., then frequency is how many of each you got. How frequently did I get a German-speaking person? So, basically, how many times you had the same observation. So here I'm going to do an example. Say, for instance, I am looking at different colored cars. I go into a parking lot and I count different colored cars. So I'm looking at blue cars, white cars, red cars, and green cars. So if I count 7 blue, then the frequency for the category blue is 7. The frequency for white might be 24. 5 red, 8 green. So the frequency, how many blue, how many red, how many white, how many green. If I now want to figure out how many cars altogether did I count, I just add all of these together. Right, so 7 plus 8 is 15 plus 5 is 22. The total is 44. So that is frequency, but then you also get relative frequency. Relative frequency. Say, for instance, what is the relative frequency of green cars? It has now again changed the color of my pen. Actually don't know how it does that, but anyway. The relative frequency of green cars. Then you take the frequency over the total. And seeing as that is a fraction that can simplify, I always simplify my fractions. Relative frequency of red is 5 over 44, and that can't simplify. You can always write it as a decimal or as a percentage. Right, so relative frequency relative to the total amount. We're going to do one more new word, grouped data. And that is most common, usually used for continuous data. You can do it for others as well, for discrete data as well. But for example, if you took the ages of children at some or other event, and that would maybe be the frequency, then if I'm saying children between 0 and 2, I don't just write 0 to 2. I write it like this, meaning if the child is 2 years old, he doesn't go into this group because it's not equal to 2. So then you would put all equal to here, and maybe that would be up to 4, and then maybe that would be up to 6, etc. So maybe there were 5 babies under 2. But if the child is 2 years old, he goes into the next category. 7 children there, and maybe 2 from 4 up to just before 6. So the reason why we write it in this way is so that if a child is on the boundary line, the 2 or the 4, etc., I know exactly in which group to write it. You can see if I wrote 0 to 2, 2 to 4, 4 to 6, then here I wouldn't know where to put the 2-year-old and the 4-year-old. So it's better to write it like this. And X is usually just used as the data. So if we read this one, we would read the children who are aged from 0 up to just before 2. And there were 5 of them. So that's grouped data. That means we know there are 5 children under 2 years old, but we don't know their exact ages. So it's usually used for continuous, because if you took children under 2, some could be 1 year, 6 months, some could be 1 year, 6 months, and 1 day. So because it's something you measure, it's just better to put it in groups. But even if it's discrete data, if you have a huge amount, a huge number of children, you would still group it so that your info isn't so enormously big.